Hi, everyone. This is Alan Schimmel, Editor-in-Chief of DevOps.com. Thanks for joining us on another webinar today. Today's webinar is sponsored by JumpCloud, and it's on SSH Key Management Fundamentals. We'll get started in just about a minute or so. We realize everyone is busy, and we'll give them a little time for late arrivers to join in, and we'll be started. While we're waiting, for those of you who are new to our webinars, we do use the Citrix GoToWebinar platform, and one of the nice things about it is there's a separate section. If you look in your top the webinar control panel, there's a separate section where you can ask your questions. You do not have to, we have set aside a section for questions at the end today, but you do not have to wait until then to type your questions in, as we find many people sometimes forget their question when it comes time for the question and answer session. So please feel free to type in your question, and we will get to them at the conclusion of the webinar where we've set aside time for them. Additionally, you can also chat with others if you'd want to, and we can try to answer any questions that come in there as well, though the question section is the preferred method. Also, we will be doing some polling questions today to help gauge sort of where the audience is and how you feel about certain issues, and you can look for those during the webinar. They will pop up. That being said, we'll just give it another 30 seconds or so, and we will get started. Okay. All right, I think we're going to get started. For those late arrivers, welcome. My name is Alan Schimmel, Editor-in-Chief of DevOps.com. Today's webinar is sponsored by JumpCloud, and the topic is SSH Key Management Fundamentals, and we're very lucky to be joined today by Mr. Topher Marie, co-founder and CTO of DevOps.com.
Am I?
Topher?
Hello, how are you? I'm actually CTO and co-founder of JumpCloud. You gave me credit.
Did I say DevOps.com? No, you don't have anything to do with DevOps.com. Sorry,
well,
Topher. Just making sure we were listening. Okay. So Topher, co-founder and CTO of JumpCloud.com. Nothing to do with DevOps.com, other than a friend. As you can see from Topher's quick about me slide, prior to JumpCloud, Topher was at Simplified, and prior to that, Ping Identity. So a lot of experience in the identity access control space, and that's Topher's passion, frankly, is within there. And you could see his alphabet soup of interest and so forth that he likes underneath that. And I'm sure he's going to explain what some of those may mean for those of us who don't know. But even I know most of these, so I'm assuming most of you do well as well. Topher, welcome to DevOps.com webinars.
Hey, Alan, always a pleasure, and thanks for having me, and thanks to everyone for joining today.
All right, we're going to turn it over to you, Topher. Just before we begin, another just quick reminder, guys, if you have questions, type them into the question section, and we will get to them as we've set aside time at the end, firstly. And secondly, yes, this webinar is being recorded, and yes, the webinar itself and the slides will be available on DevOps.com within 24 to 48 hours of the conclusion of today's webinar. Topher, take it away.
All right, thank you, Alan. So yeah, I've been working in identity management for the last 12 years or so. Ping and Simplified are more on the web access side with SSO, SAML, OAuth, OpenID, etc. JumpCloud now deals more in system-related access and identity within your infrastructure, but not exclusively. So I've been building these identity management systems, and I've also operated heavily as a consumer in that space. With a DevOps mindset, I've set up dozens of infrastructures for employees and colleagues as users, and today I'll just be sharing some of those experiences. Specifically, we'll want to talk about SSH or Secure Shell access for Unix. Let's take an overview. The agenda for today, so first we'll talk about the what, the public key security fundamentals. Then we'll do the how, so some various experiences that I've had with public key management. And then a little bit into the where, so different infrastructure as a service environments that I work in and maybe you guys work in too. And then, as Alan has said, we'll close off with some Q&A. But first, the foundational stuff. And why do we care about that? Well, to me, it's sort of analogous to learning to work on cars. I used to rebuild Jeeps as a hobby, and I could just follow the instructions from the Chilton's manual or whatever, and at first I did. That's how I started out. But as time went on, I found myself learning about compression ratios and displacement and really having a deeper understanding, and that helped me to become a better mechanic or engineer. I think that's analogous here. I think that understanding what we do with security makes us a lot more effective at doing it. So with that said, these are the three fundamentals of network security. First is confidentiality. If I send a message to someone, I want to know that only they should be able to read that message. The second is integrity, so that when I receive a message, I want to know that it hasn't been altered in transit. And finally, authentication. When I receive a message, I should be confident that I know who it actually comes from. And that leads us into public key cryptography. So public key cryptography has been around since the 1970s. A lot of it was pioneered by three mathematicians, engineers called Rivest, Shamir, and Alderman. Alan, do those names ring any bells with you, perhaps?
I thought they were a law firm. No. I actually have heard of them, and only through things like the RSA conference and stuff.
Exactly, RSA, Rivest, Shamir, and Alderman. And you know that if your name has been taken as an initial for a multi-billion-dollar company, you probably made a pretty big impact on what you're doing, your work. And actually, I don't think it's hyperbole to say that RSA, the algorithm in public key authentication, is really a backbone of where the internet stands today, and probably trillions, literally trillions of dollars of revenue go through the stuff that they have developed. So public and private keys, these are generated in pairs, and each pair is mathematically linked with special properties. So a public key can encrypt a message which only its private key can decrypt, and this gives us that confidentiality that we were talking about in the last slide. Going the other direction, a private key can sign a message, and its associated public key can validate the signature. This assures us that the holder of the private key actually sent the message, giving us that authentication I was talking about, and also that the message wasn't altered in transit, giving us the integrity. So you can see that the public and private key encryption can help us to be secure, since they give us the foundation for each of those three pillars of security. We can also use public and private key pairs as authentication, so that's asserting identity. Proving that you have a private key is like proving who you are via having a password. And that's also why it's called a private key. You're using it to prove who you are, and only you should have it, much like the password situation. You can give your public key to anyone, and they can use it to encrypt messages to you and to validate signatures from you, so it's good for authentication. Giving your public key out is safe. You've got to keep your private key private, though. Now, there are a few mechanisms for which you can share public keys. And I've got a funny little XKCD here, the relevant one for this particular situation. So one of the ways that you can validate that you have the correct public key for someone is by having it signed by somebody else. So if I trust Alan and Alan trusts Mike, Alan can sign Mike's public key, and I can say, okay, because it is signed by Alan, I'm going to go ahead and trust it too. There's a couple of other mechanisms. There's key servers. There's a really neat project called keybase.io, which is out there, and I hope that they really take off because we're using it a lot here, and I find it is a good way to determine which public keys you can trust or not. Anyway, all of these mechanisms really are outside of the scope of what we want to talk about today, but you do need to make sure that you have the right person's public key. Having the wrong public key is a huge vulnerability. We'll talk a little bit more about that as we go on, but first let's talk about the mechanics specifically for SSH public key authentication. Here's kind of the flow. I'm assuming here that you have a user with a private key and a server that has his public key on it. Basically, the authentication ceremony looks like this. You're trying to log in. I say, hey, here's my username. I'm Topher. I'd like to start a session, please. The SSH server says, all right, I have a public key for Topher, but I need to validate that you're actually who you claim to be. So I'm going to send down some data, and I want you to sign it with this private key. Assuming I have the private key, I'm able to sign it, but based on that signature, the server validates it using the public key. If it matches, great. I'm actually who I say I am. All of it's automated and transparent, of course. I'm not typing anything at this. It's the SSH client that's taking care of my side of it. It's the SSH server that's taking care of the server side of it. It's the client negotiating with the server on the user's behalf. So where do I get me one of these private public key pairs? Well, it's pretty simple. The most difficult part really is to make sure that you have the necessary package installed, OpenSSL. Based on that, I just type SSH-keygen. Here I'm specifically calling out the type of key I want, RSA, and the size I'm asking for 2048. Honestly, I think those are the defaults now, but calling that out explicitly doesn't hurt. It generates me a private key, puts that private key by default in my home directory under a subdirectory called .ssh. It's going to name that IDRSA. You can specify something different if you want. You can also enter a passphrase. That's recommended. That way only you, even if someone compromises your machine, only you should be able to still use that private key. And then there you go. It generates it as IDRSA, and it also generates an associated public key for you. Pretty simple. There's a caveat to this. It really should be done by the end user themselves, not by you as a system admin. If it's beyond their capabilities to do this stuff, you might conclude maybe they shouldn't be getting SSH access anyway. The point is no one else should ever have access to a private key. It's a huge vector of attack. They need to be kept safe. And as the system admin, you also want to be blameless in case of compromise. You wouldn't want to know your user's passwords. You should never have possession of their private keys. If they're ever popped, you should know that it's their fault and not your fault. Here's an example public key. This is actually my public key, and it's perfectly safe for me to share it. The worst that can happen is you use it to send me an encrypted message. I decrypt it using my private key. I get angry about it. I send a response. I can even sign that response so that you know it's from me, and you can validate that it is actually from me using this public key. But actually, there's a little bit of a complication here. So you can be somewhat sure that this is my key, but how sure? What if this entire thing is a ruse? Am I actually Topher at jumpcloud.com? You guys think so? I mean, it would be a pretty big ruse for me to run this webinar just to intercept his traffic. But if you get someone's public key, it's not actually their public key, and if you use this key to try to send a message to Topher, and I'm not Topher, I would be able to read that traffic. So the distribution of public keys is foundational to trust. And fundamentally, it's all about key management. How do I know that the key I have is actually the right one? Kind of two obvious points that I really want to highlight around this. One is that anyone who has a user's private key can get onto your machine. That's obvious. I think that's what everybody thinks about when they think about private public key authentication. The implication is that people should create their own private keys. The private key must remain private. It shouldn't be emailed. It shouldn't be shared. Don't lose the laptop. Don't allow them to have a virus that steals files off the machines. These are the things that we as system admins and DevOps personnel really think about quite a bit. But the other point is just as important. Anyone who has a public key on your machine has access to that. So you have to make sure that only the appropriate public keys are on your machine. If someone puts their own public key there, that's just as bad as compromising a private key. And we'll see a couple of examples where that's not just a theoretical thing. Huge mistakes, George Bluth. Wait, that's Job Bluth. What am I saying? So let's talk about some blunders from the past years around managing keys. Alan, I actually have a smoking jacket that looks very much like that. I only wore it to the office one.
I bet you do, Topher. I'd love to see you in that.
All right. Well, we'll have to
It's
arrange.
not crushed velvet, is it?
It is, yes. Isn't it pink?
Oh, wonderful.
It looks very much like that. Anyway, let's talk about some blunders from the past few years. So first, private keys, people screwing things up with private keys. FreeBSD back in 2012 had a developer who somehow lost control of his private key. I'm actually not sure how it happened. I'm not sure they are sure how it's happened, but someone then used it to log into the FreeBSD servers, and they had to disavow a large number of builds because of this, because they don't know what that person did once they got onto those machines. Another mistake from the private key side of things is GitHub, and it's not GitHub's fault. This is some GitHub users were uploading their private keys into public repositories. So bad guys were just scanning all of the public repositories on GitHub and finding keys. Don't know how many, if any, compromises were to blame from this, but GitHub has laudably taken a proactive approach now to protect people from themselves here. If they see that you're uploading something that looks like a private key, they'll let you know and try to tell you why you shouldn't be doing it. But like I said, it's not just private keys, it's public keys that you have to worry about too. So at AWS, AMIs, which are Amazon Machine Instances, well, Amazon Machine Instances, I'm pretty sure most of the audience here probably knows about this, but an Amazon Machine Instance is something that you can build and use as a snapshot later. So you can download other people's AMIs with, like, let's say MySQL previously installed on it, and you just use that in your production environment. One vulnerability around that is some AMIs were coming pre-installed with public keys. So anyone with the private keys for those public keys could get onto those machines. So people were using these MySQL servers in production environments, and although I don't know that anything actually came from it, someone out there with private keys had the ability to log into any of those servers. And maybe the most notorious example is Edward Snowden. Regardless of what you think of the politics of the situation, I would not have wanted to be the sysadmin in charge of securing that data and securing those servers. Allegedly, how he breached the security is just by putting his own public key in with other users' accounts. And then some period of time later, he was using his private key for those public keys to access their accounts. So it wasn't some James Bond stuff where he was stealing people's private keys. Instead, it was having the wrong public keys on those machines. So some common ways that people lose control of their servers. One is the obvious, losing your laptop storing a private key. Go ahead.
Topher, I'm sorry to bother you. I'm not seeing the I'm not seeing the slides progressing. I'm still at huge mistakes.
I've been on this one for a little bit. I'll change.
Okay.
Just
wanted to make sure we didn't mess something up.
Nope, it's me. I just enjoy the sound of my own voice rather than bullet points.
Okay, no problem.
All right, but moving on, some of the common things that people do to lose control of their servers include losing the physical hardware storing the private key. So this is when you've left your laptop in the airport, someone gets the private key off of it. Some users don't know how important private keys are, so they do something like emailing their private keys around, or they think that email is more secure than it actually is. The other side of things, talking about public keys, sometimes a user will add an untracked key. It might be their own key, and so it might be kind of okay, but you as a system administrator should really know all of the keys that live on your system and not trust that they are managing their own keys. And maybe classic example is a user is fired, but you have forgotten to deprovision their keys from your machine. Basically, you can't trust your users, and you can't trust that they know the implications of private and public key management here. I think that this one is pretty funny. I could see myself 15 years ago saying, well, maybe people would be interested in the private key side of things. That's not the way to go about it, obviously. Public keys are public. You always have to keep your private keys private. So the core here is robust key management, and this is finishing up this what section. Basically, what we're trying to do is get your users' keys onto your machines, making sure that you only have the correct keys on each machine. To me, that means really I want a centralized place to store all my keys and all of my users. I want to be able to provision a new user from one place. I want to be able to deprovision departing users from that same place. I want to be able to detect and remove defunct keys. I would have liked, in the Edward Snowden situation, to be alerted that, hey, here's this key that just suddenly showed up on this machine, so I could go investigate how did it get there. You also want to be able to enforce robustness. I haven't talked about this yet, or I won't talk about it much at all, but key size is important, and the algorithm, the type of key is important. People could be using old keys that are still small and that can be compromised. So you want to be able to enforce the robustness of their keys. And you also want to be able to force the rotation of keys. Now, I'm going to digress just for a second here. Rotating keys is kind of an interesting topic. So OWASP recommends that you rotate keys periodically, but it's not like your key decays. It's not like someone is cracking them. They're really robust. It would take a nation state like to the heat death of the universe to crack any decently sized key. But it's not really about the process it is about the process. It's not about the key decaying. It's about having a process in place for when a crisis hits. If every 6 months I rotate my keys and I have a process for that, I have practice and I know how to do it. I don't want to be going and figuring it out for the first time when I've noticed that I'm starting to get logins from China. I want to already have something in place, and having a system for rotating keys is important. All right, so now let's move on to sort of the how of key management. So the first phase I go through at any new organization or with any new set of infrastructure is manual key management. You've got a couple of users, you've got a couple of machines, you can just do this stuff by hand. But it's also good to know the low-level mechanics, even as we move on to these more advanced techniques. I'm going to assume here that you know how to add users, you can create keys, you manage SSH, all of those things. We're just going to focus on the key management itself. There's plenty of resources on getting SSH set up. I'm assuming everyone has that covered already. At its core, we just need to let the SSH server have access to a public key which is associated with a valid private key for that user. By default, this authorized keys file inside the user's home directory. You can see here it's under a subdirectory, a hidden subdirectory called .ssh. And you might note that I am appending to this file. SSH is intelligent enough to manage multiple public keys, and it makes sense to have multiple pairs of private and public keys for different machines. One for your primary machine, another for your personal MacBook, perhaps even more after that. Now, I myself, I'm of two minds on this. On the one hand, this allows you to never transfer private keys off of the medium on which they were created, so you can generate a key and never have to move it off of that box, but it also adds some complexity to managing even more keys. Regardless, SSH allows it. A lot of people use it. You also need to set some permissions on that file. SSH will properly reject any keys that are open to the world, so you see that I'm locking that down there. And that's it. That's how I can generate keys for a particular, or how I can propagate the key for a particular user onto that machine. It's quick, it's simple, low overhead, not much to it. But obviously it doesn't scale. So every time I add a new user or every time I'm updating their keys, this would involve logging on to every single machine. And that's just for provisioning. I want to recognize that deprovisioning is more important. In a crisis, you have to know each machine that's affected, every place that that user is provisioned to, and you have to be able to remove them quickly or change their keys quickly. So while manual key management is simple, it just doesn't scale with your organization. So that brings us to phase 2, using a configuration manager. And this being a DevOps webinar, many people have already jumped ahead to this in their brains. This could be Puppet or Salt or Chef, Ansible, whatever your tool of choice is. Each of these have their own mechanisms to provision users and to manage their keys. I myself primarily work with Puppet, so my example is from there. Here's a sample Puppet configuration for my user. It's simple. I've got my home directory in there, I've got groups, so basic user management, and yes, I've got SSH keys. And I can have multiple SSH public keys in there. It's relatively simple, assuming I've already undertaken the overhead of installing a configuration manager, which obviously is not not trivial to get Puppet going or to get Salt going. But once you have those things, it's simple to add your user configuration to that. And there's an ocean of documentation on this, and each manager really could be a talk unto themselves. So this is good. Now I have centralized control, and I can provision and deprovision users from one place. And I can have lots of users, and I can have lots of machines, and there's not too much additional pain from that. But there's a few downsides, and this is my sad Puppet slide. First off, it normally involves a delay to take effect, and again, each configuration manager is different, but for Puppet, for instance, if I were to be using this in my production infrastructure, it takes up to 20 minutes on each machine for it to decide to go and poll again and detect that there's a change to my user and push new public keys for them or deprovision the user. In a crisis situation, obviously 20 minutes could mean the end of the world, and I would have to log on to each of my machines and cycle Puppet or whatever it would take in order to make those take effect immediately. So that's really no better than having manual key management. The other fundamental problem that I have with this is that now my user repository is like a config file or something. This has the implication that either my admin has exclusive access, he's the only person who can get into these configuration files, or that all of my engineers, all of my DevOps personnel have access to keys. And remember, having uncontrolled public keys is just as bad as having a compromised private key. This is exactly the Snowden situation. So that means I either have to have my config manager locked down, or I have to segregate my user management from other parts of configuration management. This just starts getting to be DevOps painful for me. Really, it comes down to coupling identity and access to system configuration. I don't like having the same place that I manage software versions also be in control of my user management. Highly coupled systems tend to have troubles with maintenance, and they tend to be brittle. So I really don't recommend this approach in the longer run. It has its place, just like manual configuration, but I don't think it scales as your organization scales. So let's talk about decoupling identity and putting it into a coherent store directory. So this is LDAP or Active Directory. I've used LDAP quite a bit. It's my preference. Active Directory I've also used, and that's all I'm going to say about that. There's also 389 directory server, which I'm not sure if I can say it's taking off, but I know that some people enjoy using it. I myself have not used it yet, so can't speak too much to it. Basically, all directories have the same purpose. They contain your user information, all of the user information, like their full name, their address, their social security info, and their public keys. So this allows us to tell our SSH server to connect and request user information. You can do this using PAM or a public pluggable authentication module. I call these PAM modules, which I know is not really the right way to pronounce that. You can also use SSD, the System Security Services daemon. And the flow then is that a request comes in for authentication. I want to log into an SSH server. The SSH server then requests the public key from the directory and uses that from validation. just as before. All of the authentication part is the same. The only difference is that the public key is not stored on a file on the server. Instead, it's stored in the directory. Here's a sample SSD configuration. This is actually one of ours. What's great is it's a single place to manage my users' keys, and it's decoupled from my configuration. I can lock down access to the directory as need be, and it can be used for more than just the SSH key authentication. I don't want to get too distracted here, but using directory, you can also do password auth into Macs or Windows, and Active Directory has even more options than just pure LDAP. It has Kerberos, etc. You can also tie it into a more general user management for other parts of the company, like your HR and your payroll departments. You've got the address, you've got the social security number. Everything about all of the users or all of your employees can be in the same directory. But there are some pain points. So first off, and maybe most notoriously, setup of LDAP or Active Directory can be onerous. Many people revel in the setup of this infrastructure. They like the replication, they like trees and forests. I myself prefer to spend my time on the core competencies of my business.
Hey, Topher, it's Alan
Yes.
again. You know what, I think now may be a good time for our polling questions, or are they a little deeper in?
No, absolutely. We can go ahead and do the polls now. I think at least one of them is related to this point right here. Which directory do you prefer to use?
Okay. So what directory are you or would you be the most comfortable using? And if our attendees can vote, it's only 10 seconds. We'll give you 5 more seconds. Come on, only 33%. Let's get the other half of you to vote. And we're going to end the voting in 5, 4, 3, 2, 1. Closed. Okay. Oh, LDAP was the big winner, Topher, at 76.
Yeah.
Surprisingly, Active Directory, just 24%. But well, it's the old macaroni and spaghetti question. Is Active Directory sort of part of LDAP at some point or no?
Well, Active Directory can use LDAP, pure LDAP, as one of its communication protocols. Open LDAP is something that I'm not surprised by these results at all. Open LDAP can be installed as a standalone service and on Linux, even on Windows, and it's the more pure solution. And if you've used Active Directory, it's got a lot to it, and I mean that in a nice way, but it's also got a lot to it. And I don't mean that in such a nice way. It can be very complicated and onerous to deal with. So I'm not surprised by those results at all. I myself prefer LDAP, but then I'm a little biased on that.
Got it. Here's our next question too. Let's try to get an answer on this one. For those of you out there who are managing public keys, how do you manage your public keys for SSH authentication? And manually with something like a Puppet or Chef kind of configuration manager, with a directory or some other way? And if you can answer, we'll close the voting off here in just another 5, 4, 3, 2, 1, closed. Okay, sold. Well, is this surprising, Topher? 41% manually?
It's not surprising.
What about Puppet and Chef at 35%?
That's not surprising to me either. I would think with this particular audience, well, I would think that most of us who are managing public key access manually probably know that this is not going to scale. And maybe these are people who are smaller organizations. You've got 2 or 3 users, maybe up to 5, 6 users who aren't leaving, or you're not adding a lot of machines. Fine, that's great. And why take on the overhead of a Puppet or Chef or a directory if you don't need it yet? So my guess would be most of these people are either with smaller organizations, or they are really starting to feel the pain, and maybe that's why they're listening to this webinar. So far as the Puppet and Chef using a configuration manager, I'm not surprised by that at all based on our audience. We DevOps people like to have control over everything, and Puppet and Chef are great ways for us to have control over our infrastructure. And I think to a certain extent that's fine and that's valid. but it does become brittle at a certain size, which maybe we're not at yet. Okay. I'm not sure. I'm going to keep moving on there, Alan.
Yes, you're good.
Okay. All right. So let me talk more about the pain points of directory. First off, we already talked about setup can be onerous, and maybe that's why we have a low percentage who are taking on LDAP. Because yeah, you have to have, not only do you have to set up LDAP itself, but you have to make sure that this directory is available to all of your infrastructure, whether it be in the cloud or on premises or whatever. Your directory has to be geographically available everywhere. You then also have to configure each client to talk to it, but that's where your configuration manager kind of shines. That's a good thing for your Puppet or Chef to configure SSHD or to configure SSD to talk to your directory. Maybe the most difficult part is the need to make it highly available. Directory downtime means that no one can log in, and that's obviously a tragic thing. You can't have that. Making sure that you have high availability for a directory can be a full-time job, and you could have a full-time admin doing this. Larger companies do have full-time people, multiple full-time people, just for keeping up their Active Directory and keeping it replicated, etc. So it can be onerous. I myself ask, why am I setting these things up? Why am I managing them? There's so many things that I've been able to offload, like my mail servers, like my code repositories, even the production servers themselves. I offload all of this stuff to third parties. Mail is now handled by Gmail. My code repository is at GitHub. Production servers at AWS or GCE. This identity stuff, this directory, is the last vestige of, oh, you have to have someone who does it on site. Which brings me to the next bullet point, directory as a service. So only in the last few years has this really started to take off. It's really just now taking off, but it really is taking off like gangbusters. You see it from Azure. Amazon has some offerings around it too. Both of these are fairly focused within their own walled gardens, of course. And we're also doing it at JumpCloud. The approach is to centralize and to expose your identity to a variety of different identity consumers in a variety of protocols. So SSH key management is just one of these, shown here in the lower left. Keys are propagated as appropriate. You can specify via a user interface or via an API which users should be on which machines. There's minimal configuration of the endpoint. Often this is done via your configuration manager. Just have Puppet do the installation. And your end users can actually have a lot of control over their keys, going through the user interface, proving their identity there, and then changing out the keys as need be. The availability, meaning both geographic and uptime, are handled by somebody else whose job it is to make these things happen. So just like I don't have to worry about Exchange servers or the Linux mail servers anymore, I'm offloading these things outside my core competencies to people who do it full time. So those are the 4 different what options. Now I kind of want to move in, and we're not going to spend a lot of time on these, but the where, discussing the where of managing SSH keys, because different cloud or internet as a service providers have some different options for managing users that live a little bit outside of these that we've talked about. So let's first talk about the quote unquote native key management at AWS. So I'm sure anyone who has ever operated at AWS has seen this screen. It provisions an initial key for you on the machine, allowing you to log in as EC2 user or Fedora or whatever. And this is good for a first-time login, but it's best to remove this once the system is spun up. And it's no substitute for public key management practices. There are a few other options. One that I've done, and I don't recommend, but let me just tell you what I don't recommend here is I had a custom AMI that had preset authorized keys, kind of similar to what we were talking about earlier in the blunders and mistakes section, but with known keys for my organization. It was people within the company. It was still problematic, even though it was on other people's keys. Every time someone left or joined the organization, did that mean I'd have to rebuild the AMI? Yes, it did. and that quickly became untenable. But also I realized in case of emergency, what was I going to do? The auto scaling was going to spin up additional machines with the bad public keys on it. So that quickly became something that I just didn't go for. Amazon also has the OpsWorks option for general configuration of systems. This is really chef under the covers, which some people like a lot. I used it briefly. To me, it had all the same strengths and weaknesses that you would expect from a configuration manager. The other problem I had with it is it's also very AWS specific, but some people don't mind getting tied into AWS. I myself like to be a little more agnostic, so let me talk about the Google Compute Engine too. They actually take a very interesting approach. They have a Python-based agent that lives on the servers that manages a whole bunch of stuff. You can see here it's managing accounts and addresses. So when I add a new machine, it actually changes the etc hosts on my Linux boxes, and it does all kinds of other things here too. You can use the management console, and that agent detects changes and adds users or changes the keys on a particular machine. Really, this is marginally better than manual management, but it's still a single server at a time, and it's somewhat painful. GCE is newer, still maturing, still building out their offerings, so I wouldn't be surprised to see new things coming from them soon. So those are both examples of managing users in the cloud, and that those were the specific things available at those two cloud servers, but nothing prevents you from applying the other techniques for managing your keys. You could set up an LDAP server in AWS and have all of your AWS machines talk to that LDAP server. You could put a puppet master in GCE and have everything configured that way. They have the same pitfalls as if you were managing locally. And absolutely, you could use a directory as a service for these two. The last kind of point I want to make, and this one kind of is like fireworks. I never know when it's going to actually start here. Let's see if that does it. So this is the mixed environment. I've got some on-premise machines, and maybe I start spinning up some in a co-location. This is the jump cloud situation. I've got machines up at AWS. I've got machines at GCE. I've got machines everywhere. And I don't want to have different configuration managers and different LDAP servers. I want to have one place to manage all of these things. And this is really kind of how I view my infrastructure sometimes, just a pile of servers like that. So in the mixed infrastructure scenario, what if I have machines locally and in the cloud? What if I have multiple clouds? Well, then I really don't recommend getting bogged down into any of that specific stuff for Amazon or for GCE, obviously. I don't like getting locked into any particular cloud vendor's offering. And you could use any of these techniques. I mean, you could set up an LDAP server, but it comes with even more overhead. These directories now need to be accessible across all of these different platforms. A puppet master would also need to be accessible from not only your on-premises machines, but also the machines you have at GCE and the machines you have at your co-location. There's a lot of additional overhead here. So Jump Cloud has this particular problem, and this is really where directory as a service shines. It's really built for that scenario where your directory and its availability is handled by somebody else, and it is available across all of these different infrastructures. Basically, all I want to say is that key management is evolving. It's not really that important how you manage your keys, but rather that you do have a good key management system. And as your organization evolves, your needs will evolve along with it in terms of key management. What works for 2 or 3 people won't work for hundreds, and it definitely won't work for thousands. And as you grow, you'll likely find several different pain points around scaling, around coupling, around the overhead of running these things yourselves. As in every area of DevOps, it's important that we stay abreast of both the tried and true techniques and also the new offerings out there. And that's all I had, Alan. I'm ready for any questions.
Okay, and we do have a bunch of them. Topher, before we get into the questions, though, let me thank you. You know, this was a very technical subject that a lot of people kind of think they know about, but they really have a lot of questions and a lot of holes in their knowledge, and I thought you did a great job of explaining it. So thank you very much for that. But let's get right into things here. So Yakov Simkin asked, how does Google's Samiloa, S-A-M-I-L-O-A, integrate with subscription payment billing systems, such as like Developer and Android Google Pay billing? And is it secure? Would you know that, Topher?
Well, I think we're getting outside of the topic of SSH key management there. I think he's asking about SAML.io.
Yes. Yeah, that's what it sounds like.
Yeah, that's definitely outside of the topic that we're discussing here. But actually, if you could have him send me an email directly, topher@jumpcloud.com, I'd be happy to have that discussion with him.
Fair enough. Yakov has another question. It may also be outside. Where are the examples of Google public keys are stored and who has access to it at Google? How they get associated with a private key?
So Google has a couple of different options. So we're talking about GCE, Google Cloud Engine. The one that I like to do the most is where you spin up the machines and then you specify the public key in that user interface. A couple of slides back there. All you do is you copy and you paste the public key into there. You're asserting, hey, this is my public key or one of my users' public keys. Go ahead and just copy that into the appropriate location on the Linux box. So it will then put it under home topher.ssh inside the inside the authorized keys file. The private key never leaves your box. It's generated locally on your box, and so you have no concerns on that side. And you're asserting what that public key is and where it goes onto that machine.
Okay. Next, Yakov's a busy questioner. What percentage of publicized breaches do you think are due to sharing of public keys?
That's a really good question. That's a really good question. I'm just going to ballpark it, and I would say that of breaches that are key related, I would say it's probably, let's just first restrict it to only like SSH key access breaches. I would say that almost all of them are because someone has their public key on your machine. Let's say 20% are probably, I've managed to steal someone's private key. So you can do that by, phishing them and installing software onto their machine that then steals their private keys off their machine. But a lot of system admins are very cautious around that area. I would say that real breaches often come from the inside, and they're often the Snowden scenario, where someone has managed to get their public key into a user's list of valid public keys, and then they're able to log in and impersonate that user. And it's really sort of the sysadmin's fault for concentrating on making sure the private key is secure, but not making sure that they have the correct public keys on the machine. That's an excellent question, though.
Excellent. Next one is, what's the difference between 2048 and 1024 bits when it comes to keys?
It is 1024. No, it's a lot more secure. So 2048 means I have 2048 bytes inside of my public key, actually inside my private key. And that means that it should take a very long time for that to be decrypted or to be broken into. So there are attacks against public keys. And if I had a public key which was only, let's say, 512 bytes long, it is possible and actually within the realm of simple machines to reverse that. They can listen to the traffic, see what the encrypted traffic is, and they can break that code after some period of time. They can break the encryption. But the more bytes of entropy you have in your private key, entropy is maybe not quite exactly the right word, but the more bytes you have in your private key, the more difficult it is to reverse that and to be able to break the encryption. So 2048 is kind of the accepted value. I have heard people saying that it is still good for a while. Having longer private keys does increase the time it takes to do some encryption, but I don't think that it's something that you need to worry about at this scale. So the quick answer is the larger your private key, the better your security is.
Excellent. Which one is better in the list of tools like SSO, OAuth, etc.?
Well, so SSO just means single sign-on. That is the capability of you signing on to one place, like let's say to Okta or to Ping Identity or OneLogin or Bidium, etc. You log in one time to them, and then SSO means that they are going to assert that identity to places like Salesforce or to Google, or places that will be willing to listen to them as the identity provider. They are willing to be a service provider which consumes that identity. Then there are different techniques for which they can emit and consume that identity, one of which is SAML, one of which is OAuth, OpenID is one. Also, there's others that I'm not thinking of right off, but all of them have kind of their strengths and their weaknesses. SAML's very flexible, has a whole bunch of different profiles. If you're into programming, it's kind of like Java, though, in that there's a lot of overhead just to get a SAML assertion set up in the first place, where OpenID has less well built out scenarios around it, but it is simpler to implement. So it depends on the scenario. It depends on what you're looking for exactly. I think that OAuth right now is kind of winning that battle.
Excellent. Okay, our next one for you. Hold on here. Wow, we seem to have gotten rid of. What's the difference between DSA and RSA keys?
Oh, that's an excellent question, and I am going to blunder my way through it. It's been a long time since I've kind of taken any cryptography classes. RSA, both of those are basically just algorithms. RSA is considered to be a stronger algorithm than DSA. I don't believe that DSA is actually, I might be talking out of my butt here, Alan, but I don't believe that DSA is accepted very much anymore. RSA is considered to still be the stronger algorithm, and there are even stronger things that are coming out. So the concern is somewhat that, well, has the NSA broken RSA? Is the National Security Agency able to read all of our traffic because they have broken the algorithm behind public key authentication, and they are able to see everything that's going over the web? So there is some concern that that might be true, and that's why we're using larger and larger key sizes, so that even if they have an algorithm that instead of taking 10,000 years to break a certain key now only takes 100 days, they'll probably leave you alone if you have a large enough key, and if you're not that interesting. Anyways, there are additional new cryptography, like, oh boy, what there is. Shoot, I can't think of the term here, but there are new cryptography types that are starting to take in the marketplace, including support via SSH, so that you can log in using elliptic curve cryptography. That's what I'm looking for. The elliptic curve stuff should be exponentially more difficult to break than RSA ever is. So it's just a matter of the strength of the algorithm behind it. And there's tons of algorithms that were used for some period of time and just have fallen out completely because they were proven not to be secure.
Excellent. Topher, I don't see any other questions here in our questions section.
All right.
So unless someone has any, I think we're just 5 minutes before the hour anyway. Well, someone has I don't know if it's a question or a comment. Is it safer then to use an RSA key than a DSA key? I thought that DSA were more secure, but RSA is more compatible.
I am going to try not to talk out of my butt. I do not know 100% that this is true, but my impression was that it's not the compatibility. Like, for instance, your web browsers will accept authentication via DSA or RSA or all kinds of different ways. They really just go down a list of, I'm willing to accept identity this way. Do you have identity this way? No, you don't have this way. So they just go down a list from the most secure to less and less secure until at one point you say, listen, I don't trust the Enigma codes from World War II anymore, so we're just going to stop here. I believe that RSA is stronger than DSA, but to be honest, I would have to do a Google search, and I think that that's the way to really solve that question. But my impression, my understanding is that RSA is stronger than DSA, and if you're looking for a stronger algorithm, as opposed to just having a stronger key, the stronger algorithm, you need to start moving into elliptic curve cryptography.
Google searches always answer everything, don't they?
Yeah.
All right. If there are, Yakov wanted the presenter's email, and Topher, I thought we were doing Topher at.
Yeah, Topher at jumpcloud.com is perfectly
That's
fine.
Topher.
Yep. And actually, that's on this next slide here. How about that? There's me as my email and also as my Twitter handle. Feel free to reach out to me either way. I'm happy to discuss any further. And then I will use Google as a crutch for these questions like the DSA one.
Excellent, excellent. Okay, I think we're going to call it a wrap then. Topher Marie, CTO and co-founder of JumpCloud, not DevOps.com. Thank you very much for joining. Thank you very much for joining us today on another DevOps.com webinar. Thank you very much to JumpCloud for being today's sponsor. And thank you most of all to our members of the audience who joined in and for some great questions. We hope you found this interesting. Slides and recording will be available within 24 hours on our site. And we'll see you at the next DevOps.com webinar. Thank you and have a great day.